The solution to the question of the day is what you are about handling now. You recall that the question of the day is a box of mass 400 kilograms is being dragged along the floor by a rope inclined at 60 degrees to the horizontal. The frictional force between the box and the floor is 100 Newton. And the tension in the rope is 300 Newton. How much work is done in dragging the box through a distance of 4 meters? The work done is equal to the resultant force acting on the box times the distance covered by the box due to the effect of the resultant force. First, we need to get the resultant force. These are box, and it's to be dragged along this floor. So we have to get the horizontal component of the tension, which we are told is 300 Newton, inclined at angle 60 degrees. We want this part of the tension, which represents the force pulling it in the right direction. Also, we need to remember that friction opposes motion, and we are given friction of 100 newtons. So there is a frictional force of 100 newtons in the opposite direction. First, let's get the horizontal component of the tension. Horizontal component of T is equal to Tx. And from what we've studied, Tx is equal to the tension times the cosine of the angle. Tx will give me tension is 300 times the cosine of 60. Therefore, Tx is 300 times 0.5, which will give us 150 newtons. In effect, there are two forces acting on the box. A forward force of 150 newton, a backward force represented by friction of 100 newton. The resultant force on the box, F, is therefore equal to 150 minus 100 newton. The resultant force is 50 newton. Having obtained the resultant force, we can now calculate the work done. Work done is equal to the resultant force times the distance covered. And that value is 50 times 4, which is 200 joules. Therefore, option C is correct.